This video is designed to cover how to write proportions with labels for various problems. We'll start with this first one of 5 gallons of paint covering 130 square meters of wall space. This establishes a rate, which means that we have 5 cans over 130 meters squared, and I would prefer that your labels say cans up here or paint, and down below it says wall space. And this is our rate, so that we now know 5 cans is worth 130 meters squared. So 10 cans would be 260 meters squared, and so on. So you could come up with very simple equivalent fractions to know how much wall space you would cover with a certain number of cans, but this specific question is how many cans will be needed to cover 208 meters squared of wall space, and therefore our proportion appears as such, and our goal is to figure out what n is to make this proportion true. To solve this problem, we simply cross multiply or find an easier way to find the equivalent fraction. In this case, cross multiplying is fairly straightforward and is probably the simplest way, which means 5 times 208 will equal 130n. You may ignore the units once cross multiplying because your proportion has established what the units are, cans on top to wall space on the bottom. So we get 5 times 208 equals 130n, and we solve that by multiplying 5 times 208, which gives us 1040 equals 130n. We would divide both sides by 130 to get one n by itself, and that will provide us with the solution of 8 equaling n. This works out exactly, so it's 8 cans would be your answer. 8 cans will cover 200 square meters of wall space using this proportion. In this second slide, we have a similar kind of problem where we have 75 cc's, which is a way of abbreviating cubic centimeters, of maple sap that can be boiled down to make 2 cc's of maple syrup. In other words, the process reduces 75 cc's of the sap that you take directly out of the tree to 2 cc's of pure maple syrup. So once again, that establishes our rate, and so we can write a proportion that says 75 cc's over 2 cc's, and we can write cc's, but this doesn't help us keep track of where our units, where our appropriate numbers go, and so once again it's important to put the labels in and say that this is going to be sap, which is the stuff you get directly out of the trees, and this is going to be syrup, which is the product that you get to put on your pancakes. So we've got a rate, once again, and our rate is established by the given information of 75 cc's of sap being worth 2 cc's of syrup. And so the question is, how much maple sap, which is the thing we don't know then, would be needed to make 9 cc's of syrup. And so to complete our proportion, it looks like this, and we're comparing sap on the top to syrup on the bottom, and so when we solve this and get an answer, we will have cc's of sap. Once again, cross multiplying provides us with 75 times 9 equaling 2n. So that proportion yields the equation 75 times 9 equals 2n. 75 times 9 is 675, and that again still equals 2n. We divide each side by 2, and we get that n is equal to 675 divided by 2, which is 337.5 cc's. So we need 337.5 cc's of sap to make 9 cc's of maple syrup. Of course, you should always check that this makes sense in your proportion, and so 2 goes into 9 4.5 times, and 4 80s is going to be 320, so we know that this number is in the ballpark and gives us a reasonable answer, which you should always check whether you use a calculator or not. So this proportion was a little more difficult than the first slide because we needed to find exactly sap versus syrup, and the units didn't help us, whereas in the previous problem the units of cans told us where the cans of paint goes, and the units of wall space told us where to put the wall space, whereas this cc's doesn't help us, so we have to be more precise and use labels that says we're comparing sap to syrup. So in this third proportion problem, we have established that there are 8 games won and 6 games lost. So we should write our rate: 8 wins and 6 losses. And that establishes our rate, and it makes it look like should be a fairly easy problem, except that the information we're given is that there are 21 games, meaning 21 games played. In other words, 21 games played, and that's a different comparison than wins or losses. So this is exactly the kind of proportion problem where the idea of knowing 2 things on a side tells you the third thing is really important. So off to the side, you should probably list that you have 8 wins and 6 losses, and that means you have played a total of 14 games played, which allows us then to say, oh, we're not going to use 6 losses down here. In fact, we're going to use 14 games played, and that allows us to match our proportion so that we are writing a true proportion with 21 games played. And so, of course, our labels then on top are wins, and on the bottom are played, and we have a proportion that's allowed to be true as opposed to comparing the wrong things. This proportion now has wins to games played instead of wins to losses, and since we're given 21 games played, we need to use the information of 14 games played. From here, it's fairly simple to once again cross multiply. So 8 times 21 equals 14 times n. And of course, this could be solved by doing equivalent fractions and recognizing that 14 goes into 21 1.5 times. 1.5 14s is 14 plus 7 is 21. So 1.5 eighths would be 12. And let's double check that by cross multiplying and getting 8 times 21 equals 14n. This gives us 8 times 21 is 168. So 168 equals 14n. We'll divide both sides by 14 and we'll get magically 12. So n equals 12 12 wins if the rate holds true of playing 21 games. So it's very important to note as well that if a baseball team has won 8 and lost 6, that doesn't guarantee that the ratio will continue. So in every proportion problem, when you're writing equals and making a proportion, you are making assumptions about the rate staying the same over a longer or shorter period of time, and using that to write the proportion. Otherwise, it couldn't be equal.